Hey, so I'm going to be explaining the differences between average rate of change and instantaneous rate of change, both in how they work geographically on a graph, and also how they work algebraically so you can find instantaneous as well as average rate of change using basic equations. Starting with the average rate of change, looking at the geographic side, average rate of change is typically defined through concavity, right? We've been working with concavity all year. All of you guys know concave down, frown, concave up, smile. Whenever your graph is concave up, you are moving positively. Your average rate of change is positive. You are increasing. Whenever you're concave frown, your average rate of change is negative. You are decreasing. Very basic, doing this all year. Going into the actual equation, this one's also very easy. It's y2 minus y1 over x2 minus x1. That means that if I had the point 120 and 12 to 11, and I said, what's the average rate of change between these two? I would literally just go in, put 20. Please ignore how bad this looks, but just follow my process. 20 minus, wait, no, my bad. Flip that. 211 minus 20. And then on the bottom, you do 12 minus 1. And then you would just solve that out. So 211 minus 20, that's going to give us what, 191? And 12 minus 1, that's going to give us a solid 11. Then you would just divide that, take out your nice calculator, which I now have to grab. And 191 divided by 11 is 17.36 repeating, right? This is your average rate of change. That is how you get it. It's very simple. Moving into the instantaneous rate of change, this one's a little bit weirder in my opinion, but it is definitely very important for you to know. Geographically, instantaneous rate of change is mostly found, again, with this concavity graph, and the most important thing to understand is that at points of inflection, or like your extrema, right, your minimums and maximums, your instantaneous rate of change will always be 0. A fat 0 for each and every single one of these. Please ignore how bad those look. This is just what it is. Because you're switching from positive rate of change to negative or negative to positive, your instantaneous rate of change is going to be 0. But what if you have to find instantaneous rate of change of a specific point or a specific sum of points, right? Then you will need to do this thing called finding the prime version of a function, right? So the prime version of a function, adding a little prime right there, is basically just f of x, but you're going to have this little tilde at the top of it. And that is what we use to find instantaneous rate of change because it gives us the tangent line of the graph at that specific point. It's a little bit weird, but to do like the basic, if your graph is f of x equals n, right, like whatever this point is, you're going to be putting n here, and you're going to do n minus 1 up here. To put that into perspective, let's say we have f of x cubed, we take the 3, and we put the 3 here, and we subtract 1 from the cubed, now making it squared. It's just very simple. Like, this is the main thing that you're going to need to remember. That equation gives you what you need to find instantaneous rate of change. Now, you literally just plug in what you get into that value. If they're telling me what is the instantaneous rate of change at x equals 1 for this graph, I just plug in x equals 1 into the function. 3 to the 1 cubed equals 3. And that's going to be your instantaneous rate of change at that specific point. There are other ways that you can do this, so if you're adaptable and you know how to do it, do your best. But this is the way that I've learned and I've been doing. And I find it not that hard once you just like remember the equation. I think that that's mostly it. I know that this is like a more basic topic, but I hope that I was at least able to teach you something primarily on the instantaneous rate of change side. I'm not that good with it. Now I'm going to do better with it. Now I actually know the equation for it. And hopefully you do too. Thank you for watching. And bye-bye.